designed to be a companion to the morning class that I've been giving all week, which is a 45-minute overview of ModelOps and some detail around the ModelOps essentials. It is assumed that you have a general understanding of ModelOps, but I'll also cover some of the very basics very quickly if you have not attended the morning class. This is live, and so feel free to make it interactive. There's quite a lot of material to cover in a 30-minute window, so I won't pause for questions, but I encourage you to interrupt with questions. I won't be able to see the questions as I'm talking and looking at the material that I'm presenting to you, but Linda will if you put it in your chat window or raise your hand or put it in the QA window, and she'll get my attention and we can answer questions and make it interactive along the way. It is assumed that you have a responsibility for, involved in, employee of a large Fortune 100, Fortune 500, or Fortune 1000 type organization that has committed to a real investment in enterprise AI that generally starts with machine learning and AI and other advanced modeling techniques and data science activities happening in the business units to solve specific problems. And that leads us to the operational requirements for the technology center and the CIO, which is called ModelOps. And so today I'm going to focus on pitfalls. All of the information I'm giving you today is based on our experience at ModelOps, helping large enterprise organizations develop a world-class ModelOps capability. And that's all we've been doing for the last 4 years, where we don't, and we have a solution that allows a large organization to scale that ModelOps capability to allow for full governance, deployment, and monitoring of all models in the enterprise in production. So this is geared toward those who are involved in the production journey for models, which includes obviously the data scientists who created them, but more specifically, those operational capabilities to keep them running for months, even years, in an automated fashion in the enterprise. So without further ado, let me just, here's a quick slide of who we are at ModelOps. I'm not gonna, there's plenty of ways to learn more about us. I urge you to go to our website, et cetera, but we've been defining the ModelOps category for 4 years. This is all we do, focus on ModelOps in the very large enterprise. We're the world's leading vendor for ModelOps, and obviously focused on integrations for all models, no matter where they came from and no matter where they're going. So we don't have any agenda in model development tools or data science tools or data platforms or cloud or IT platforms. We're 100% focused on ModelOps. And again, I covered most of this in detail, in some more detail in the morning session, and there'll be another morning session tomorrow morning. So please check the schedule, and I'll be giving this session again tomorrow afternoon. So you know, please, if you find any of this material beneficial to you and you think it would be beneficial to some of your colleagues, I encourage you to invite them to the morning session or attend the morning session yourself if you didn't this morning already. We'll be doing this tomorrow morning as well, and maybe even more, I don't know. Feel free to give feedback as well on more. What we're talking about is what is required for the CIO's organization. What's required for the CIO's organization to be a partner with all of the data science activities in the business units, the federated data science activities in business units, to get those production models deployed in a scalable, reliable, repeatable fashion. There's plenty of research about the challenges of that. This slide talks about what Gartner calls the AI gap. Quickly, you know, they did a survey in 2018, 23% of organizations said they would deploy large, AI models and ML models into production. In 2019, only 5% deployed. And they continued this study in 2020, and the trend continued. So there's quite a lot of discussion about those challenges at a very broad level. Our experience helping organizations address that challenge, what is called the kind of operational gap in AI. The specific challenges fall into three categories. One, models are not like conventional software in many different ways. DevOps as another operational capability is inadequate for models. And there really isn't an owner structure around the operational capability for enterprise AI model ops with appropriate roles and engagement roles. Obviously, for our customers who are much farther along in the maturity journey, these problems have been solved. But for the for still quite a number of large organizations, these are still fundamental problems. Unlike in the last 2 years, I would say, and we've been doing this exclusively for 4 in the large enterprise, ModelOps has become a widely recognized capability. Here's some Gartner research that very clearly articulates ModelOps compared to DataOps and DevOps. So it's a thing. And again, I go into more detail about ModelOps generally in the morning session. I covered this a lot in the morning session, which is how the technology center, the CIO's organization, needs to evolve to support all the federated data science activity with the different tools, whether that's Dataiku, Data Robot, H2O, Jupyter, RStudio, all of the different specific tools that data scientists might use to solve specific problems in lines of businesses, build specific candidate models, do exploratory data analysis, and all of the different activities in model creation, what is often called the model factories. In order for the CIO's organization to be the partner for that federated data science activity, 2 new roles are required: the model ops engineers and the enterprise AI architect, and they interface seamlessly with the other operational capabilities on the bottom, data ops, DevOps, and IT ops, around a very well-defined model ops capability. And then other organizational components like compliance must be seamlessly integrated as well. Again, I cover quite a bit of that in the morning session. So who we are at ModelOps, we are the leading company to help a large organization develop this model ops capability. We have a variety of different ways to get started with us, including workshops and fast projects to establish kind of how ModelOps starts to work, and then the ability to help you scale and govern at the enterprise level for years to come. Quite a bit of training and other materials, and we have a software product that is really becomes foundational for that enterprise AI capability called ModelOps Center. And I'll even demonstrate some of the key topics that I'm covering today in ModelOps Center. But today I really want to focus for the next 20 minutes on key pitfalls, things that we have found through experience have been challenges that large organizations face in adopting a ModelOps capability. And we offer that to those of you who are, either beginning on your journey or kind of maybe have some maturity issues in some areas of ModelOps, to avoid these pitfalls. And again, these come right from our experience in working with the Fortune 100, Fortune 500, Fortune 1000 over the last 4 years. This is the document you'll be given at the end of this masterclass. So you don't have to take copious notes, but you're welcome to, and give us feedback, please. But let's just start with the kind of most critical, which is having an accountable and empowered owner for the operational capability that needs to partner with the data science and model creation capability embedded in the business units using specific tools. So this operational capability needs to be owned by somebody. I will tell you that, in our experience in the last 4 years, for the first 2, even for the biggest organizations, our earliest customers, it wasn't quite clear who the ultimate production owner. We had a suspicion, but the models were being created in the business units. And so, there was an opportunity for different types of ownership. But today in 2020, and clearly demonstrated by our longest customers, as well as all of our recent customers, and even what's happening in the marketplace, the CIO has really emerged, or the technology center owner has emerged as the role to own model ops, the ability to govern, monitor, and deploy models 24/7 in production. And I'll remind you that these models are often in production for a long time with complicated retraining, complicated champion challenger type automations that are very sensitive to changes in data and other things, and often are executed in environments that are completely locked down from the data scientists. They may have security requirements, PII requirements, other types of requirements. So it's a truly operational capability, and so it naturally falls into the CIO. So not understanding that can really slow down a large organization's adoption of ModelOps as a capability. This is another one. It's really less of an issue today. This is a big issue early on for us, as we were helping big organizations in finance, insurance, manufacturing, and retail. But the failure to recognize that there's an enterprise mission for AI, because everybody's busy. The data scientists are busy solving specific problems for specific business units with specific tools and specific data sets. The data ops folks are busy kind of curating the data for the enterprise for all of the different consumers. DevOps folks are busy, getting as much software deployed into the enterprise as possible in the fastest way. IT ops is busy with the journey to the cloud and all the security requirements. So everybody's very busy. So without a strategic investment in enterprise AI, it's very hard to get an organization to fully invest in a ModelOps capability, which is the needed capability to get models deployed into production reliably. And so the symptom of that, is that a ModelOps capability is not invested in, and models build up in the business units and don't get deployed. And the market now calls that a very specific challenge called model debt. And so your ModelOps capability has to draw down that model debt. But the kind of big picture is, hey, most organizations are just now, in the early stages of investing in maybe a 5 or more 10-year enterprise AI journey that will transform the organization. And nothing could be more important in these obviously volatile and uncertain times. That the ability for a large enterprise to react quickly, to respond efficiently to changes in their operating and business environment could never be more important, and obviously more important than in the current situations we're in various different markets. So, but again, I would say for us, if there isn't that model debt, if there isn't some understanding that enterprise AI is an enterprise capability, then we tend to, not have a lot of, those aren't our customers. So pitfall number 3 is probably the thing we really address the most when we get fully engaged, which is the kind of idea that, hey, before we invest in ModelOps as an operation, we got to get our data strategy together. We've just been kind of ad hoc giving data to data scientists. They've been using their own tools for exploratory data analysis. The derivatives from those don't get flown back into the kind of enterprise data lake or data mart. We don't have any way to kind of comprehensively say exactly where all the data is and have a comprehensive data governance standard. So unless we do that, we can't do ModelOps. This is if you take one thing away is urge your organization not to fall into this trap. This is a really challenging pitfall for large organizations. One way we try to demonstrate it to folks is to point to the FANG companies, the Facebooks, the Amazons, the Netflix, the Googles, who actually, are model driven. Now they have a much more focused business. They're not like the large diversified enterprise. They usually have 1 or 2 major lines of businesses and full stack control of their entire data flow, all the way down to the endpoints of acquisition and AI decisioning, like an app, for example. But what they have understood is that as their ML and AI capability has matured, models become increasingly the #1 consumer and #1 producer of data. And so that's not always obvious to the large diversified enterprise, that's the journey the enterprise is inevitably on. And so, for example, models that get into production have very specific requirements about where the data will come from for production scoring, which may be quite different from where the data was in terms of a sandbox to build a model on historical data that might have been scrubbed or cleaned or otherwise curated. So And once the model is producing scores, that has to be created and feed back into the overall system. So and these models may be coming from many different business units and many different tools, and have different stages on the life cycle. So concrete schema contracts and concrete data requirements and data drift requirements for specific models actually starts to shape and prioritize the data ops capability fundamentally. So it's really a benefit to the data ops capability to have model ops being developed in parallel, because you have very concrete consumers and producers of data in these models that help drive that strategy overall. So now's the time to invest in model ops, not to wait for a day in the future when the already challenging data ops requirements are somehow settled, which we don't see that ever converging without kind of something driving from the top. Pitfall 4 is kind of the next most important one for most large organizations. Assuming that DevOps is just sufficient for model ops. I covered this in the morning quite a bit, some of the differences between models and traditional software. But I think the key is to understand that DevOps is not sufficient. DevOps needs to be fully leveraged for model ops. All the CI/CD tools, all of the agile development tools can be helpful. Also in the model factories and the business units with the data scientists who are not developers, they have very powerful tools like Dataiku and Data Robot and H2O and Jupyter and RStudio and lots of open source. And so they have their own activities that need to be organized in some way, but the products of that are models, and models have a very distinctive relationship to the business in terms of accountability, exposure to risk, for example, and top line results. So a model that's put into business may affect dramatically the way a trade is facing, or specifically what customers are targeted for certain sorts of campaigns, or specifically how certain production, manufacturing lines are optimized. These have tremendous business impact and could change just on a retraining, for example. So to be able to have the governance move along with the speed at which models change that is based on data and algorithm is a real challenge in model ops that doesn't really exist in DevOps. And of course, all of the different components, the data richness of model ops, and the differences in terms of runtime requirements. For example, some models might have to be in the cloud because the applications that they're feeding require low latency. Some models might need to be on-prem because of PII requirements in terms of execution, et cetera, et cetera. So each model has a variety of different business and technical requirements, and DevOps is not really set up for the diversity of requirements, and especially the business requirements in terms of approval and governance that models have versus traditional software. But certainly, DevOps should be fully leveraged. So, you know, a little farther down the maturity curve, once a model ops capability really starts to take hold in an organization, it's been our experience that the next topic that tends to come up is, wait, don't the business intelligence tools, they're talking about AutoML, and they do a lot of regressions and charting, and they really help with our decisioning process. But the BI tools are not the model, you know, the data intensive decisioning models that are coming out of the data science, ML, and AI realm to solve specific problems, but they need to be integrated with. So being able to clearly separate where BI tools are maybe adding AutoML and how that differs from fundamental proprietary models driven from historical data and modern algorithms using data science tools like Dataiku, that is an important pitfall to cross once a certain level of maturity is reached from the organization. And really, this tends to be, again, a lot less of an issue today. Early on, there was a lot of question as to whether the data science and machine learning workbenches would provide enterprise-ready model governance that is kind of appropriate for the federated model ops requirements, being a partner for all those different model creation platforms. And I think there's kind of evidence, those workbenches have a very specific constituency, and they're all very, very strong in serving the data scientists, serving those folks who are working with specific data sets, specific algorithms, solving specific business problems. And that's a very big challenge. And there are many great tools that do that. And they all have started to kind of focus on where they're really good with these types of problems or those types of data. Robot, for example, very good at automatic searching of hyperparameter spaces. So they have a big job to do to serve the data science community. It is, by definition, a model ops solution has to be inclusive of models wherever they came from, regardless of their business and technical requirements. So by definition, model ops as a capability must have no agenda in building models. Similarly, it can't have any agenda in data management, nor any agenda in IT ops and cloud platforms, and no agenda in any specific business problem. Model ops must coordinate all of those requirements on a per model basis and provide the scalable governance needed to manage models on the enterprise scale. So that's the 6 pitfalls. I'll switch quickly to give you a little bit of a demonstration about ModelOps Center. So, and just in the morning, I talked about a day in the life of the model, give you a sense of the roles of the model ops engineer and the enterprise AI architect. Here, I want to just show you a few different things that are more about some of these pitfalls. Again, let's take looking at a model as an asset that encodes all of the valuable proprietary decisioning that the algorithm used to train the model or develop the model was able to iterate over to create this decisioning asset. That should be neutral in terms of where it came from, and be able to be managed, and then be a very concrete asset for all of the constituents to be able to say, yes, that's the model that's going into production. That's the model that has to move through a life cycle, right? So, for example, every model has some source, right? It is software in that sense, but it might have critical attachments, which could parameterize certain aspects of the model in production. And those attachments may need to be developed through another, reiterated or retrained from a different process even in production, which could be very challenging to automate over time. Very clear contracts with data ops, right? So here, and very, very clear contracts to what the semantics are for production, what has to be initialized, how do you score in production, what are the metrics functions, what are the training functions, right? All of those should be, for a long time, model interchange formats and other ideas tried to force a structure on models. It's been our experience that a best practice for model ops is to allow that structure to conform to the models to map these structured semantics into whatever functions are available in the different languages and from the different packages. And of course, we need to be able to run models in environments, right? So again, an environment might be in the cloud, it might be a streaming model, it might be a batch model, it might be a REST model. And through its model lifecycle, it actually may need to change that. And we have to be able to guarantee that the model itself, in terms of trained coefficients and code and libraries, are exactly what we intend to be there. So you might do RESTful testing in some sort of user testing or QA framework, and then move it to batch for another large scalability testing, and then finally deploy it as a streaming model. We've seen such things. So, we have to be able to say exactly the requirements of the model in terms of where it came from, libraries that is required, et cetera, et cetera. So it can be matched to the appropriate endpoints. So some models might require a runtime of a proprietary endpoint like Dataiku. If certain sorts of proprietary data pipelining was reused, then it may require it be deployed on a proprietary endpoint like that, or a proprietary runtime. Some models may be distributed, take advantage of an existing distributed asset like Spark. Other models may need to be put into, we see a lot more models coming from open source engines, RStudio, Jupyter, and there is no runtime. Obviously, we provide one as well, but we should be able to say exactly how the model got deployed, all the approvals, all the governance, and everything, so that it's very clear how the journey of the model from time when it was a candidate all the way to production. And I cover some of those details again in the morning. And an asset like this has to be described for all the models and model patterns, and that's the job of the enterprise AI architect. So this tool is used by the model ops engineers and the enterprise AI architects, and interfaces with all of the other tools that data scientists and data engineers and data ops engineers and IT specialists would use. And all of this can be integrated into existing processes, especially layered on top of a DevOps capability that you've already invested in. So for example, in ModelOps Center, everything is that you saw or see is also a RESTful endpoint and can be fully scripted and fully scalable in terms of being able to manage thousands or tens of thousands of models in production across a large diversified enterprise. Okay, that's all the time we have. It's, again, a lot of material to cover in 30 minutes, but those are the main pitfalls. You have the pitfalls document. Feel free to widely circulate it. I'll be giving the morning masterclass on ModelOps more generally, 45-minute session tomorrow morning. I'll also be giving this session again tomorrow afternoon. I encourage you to invite your colleagues if you feel that aligning the organizations for and preparing to invest in a ModelOps capability is what your enterprise or the enterprise you're related to really needs. And we're here to help in any way we can. This is all we do. This is all we've ever done. And we're excited to help you and your organization develop a world-class enterprise ModelOps capability.
Thank you, Stu. And again, thanks everybody for being on this masterclass. Send us any feedback, question, and you will receive an email after this masterclass with all the links and documents. Thank you so much. Bye, everyone.
Thanks, everyone. Have a great day.